Hi, everybody. In this video, we're going to talk about scatter plots. Scatter plots are pretty simple. Scatter plots are simply graphs on which individual points of data have been plotted. Scatter plots can be used to show if a relationship exists between variables. All right, so let's take a look at this example over here. 6 students took a final exam. Below is a chart showing the number of hours they studied, their height, and their score on the exam. Below the chart are 2 scatter plots. The first compares the study time to the score, and the second compares the height of the students to their score. All right, so here are the 6 students right over here. We have Larry, Barry, Harry, Gary, Mary, and Cornelius. And in this first row, we can see how long each student studied for the exam in hours. So Larry studied for 5 hours, Barry studied for 3 hours, and so on. In the second row, we can see the height of each student. So Larry is 5.6 feet tall, Barry is 5.1 feet tall, and so on. We have all the heights there. And in the third row, we have the scores on the final exam. So first of all, let's take a look at the points on the scatter plot, just so we understand what these points mean. So for example, on this first scatter plot, we have time in hours on the x-axis, and we have the score on the y-axis. By the way, you can see from here to here, I jumped from 0 to 50, whereas all the other scores are going up by 10 on the y-axis. And that's why I put this little zigzag over here to show you that I made that jump straight from 0 to 50. So anyway, this is time versus score. And what does this point over here mean? This point means, this point means that this student studied for 4 hours, and it looks like that student's score was a 70. So which one was that? That would be Gary over here. He studied for 4 hours, and his score was a 70. Okay, let's do another example. This student over here studied for 6 hours, and her score was a 93. That would be Mary, studied for 6 hours, and the score was a 93. You can see for yourselves that I've just taken the data from this row and put it on this scatter plot over here. And for this scatter plot, I did the height versus the score. So I have the height here on the x-axis measured in feet, and I have the score on the y-axis. And well, here I just started the y-axis at 50. So anyway, what does each point here mean? So this one means that this student is 5.4 feet tall and scored that's about a 63. So that would be Harry over here, who's 5.4 feet tall, and he scored a 63 on the exam. Let's do one more. How about this student is 5.6 feet tall, and he scored a 100. Which one was that? Okay, so I just realized I had made a small mistake. This, if you rewind a few seconds, this said 87 before, but I just fixed that. It should have been 100. And now this whole table does match up exactly with this scatter plot over here. So this point over here, that was Larry, okay, who studied for 5 hours, and he got 100, and he's 5.6 feet tall, and he got 100, okay? All right, so what these 2 scatter plots, I should say, allow us to do is they allow us to see that there is a relationship between the time someone spends studying and the score that they get on a test. We can see that, we'll talk about this a little bit later in another video also, but we can see here that there is a positive relationship, a positive correlation between the amount of time someone studies and the score that they get. And that just means that the more they study, the higher their score would be. Okay, if it were a negative correlation, then that would mean that the more they study, the less their score would be. But that's not really what we see in real life, right? The more you study, the higher your score is most of the time, okay, generally speaking. So we could say, for example, this student over here, Mary, studied for 6 hours, whereas this student over here, that was Larry over there, studied only for 5 hours, and Larry, who studied for less time than Mary, ended up getting a higher score than Mary. So it's not exactly what we see for every single data point, but generally speaking, we can say that we can see from this graph that the more somebody studies, the more likely they are to get a higher score. So I'm going to scroll down now to this over here, trend lines. A trend line is a line which is drawn through the data. A trend line is meant to give a rough idea of the trend we see in the data. All right, and I'll get to this sentence later, but let's just go read from here to here right now. So if I wanted to draw a trend line through this scatter plot over here that gives me some idea of what the relationship is between time and a student's score on the exam, I would draw that trend line something like this. Okay, very simple. I'm just drawing a line through the dots like that, which is giving me an indication of what I see from the scatter plot, which is that if somebody studies for a longer amount of time, so as we move to the right over here on the x-axis, as we're going this way, then their score is more likely to go up. Okay? Now, can I draw a trend line let's take a look at this scatter plot over here, which is height versus score. Can I draw a trend line for this one? Is there a relationship between a person's height and the score that they get on a test? If they're taller, are they more likely to get a higher score? Or maybe if they're taller, are they more likely to get a lower score? Well, no. For this scatter plot, the dots seem to be spread out pretty much randomly. It's not really clear that they're moving up or they're moving down. They're just sort of splattered onto the graph. Right here, we could see very clearly that there was a positive correlation, that these dots were sort of moving up and to the right. But here we don't see that. Okay, so here what we can see clearly is that there is no relationship between height and score. So somebody's height is not an indication of if that person is likely to get a high score or a low score on a test. All right, so let's just move on and let's try drawing some more. So for this one, we wouldn't even bother drawing a trend line because there is no trend. There's no relationship between height and score. All right, so I'm going to continue with a couple more examples. All right, so let's practice drawing a few more trend lines. It's very simple. All we're going to do is we're going to take a look at the data. We're going to just try to spot with our eyes some general trend in the data. And then we're going to draw a line which is representative of that trend. So over here, we can see that these dots, they're kind of moving up, right? As we move from left to right, the dots are sort of moving up in a line like that. So if somebody spends more time at the gym, I didn't put exact numbers on the x-axis or the y-axis here, but we can see that over here, if the x-axis is hours spent at the gym and the y-axis is calories burned, we can see that the more time somebody spends at the gym, the more calories they burned. So for example, this person over here that would be a very high number on the x-axis, so they spent a lot of time at the gym, and even though I didn't put the actual numbers in, this would be a very high number on the y-axis. So they spent a lot of time at the gym and they burned a lot of calories, whereas this person over here spent not so much time at the gym and they did not burn so many calories. Okay, even though I don't have the numbers here, this number would be less than this one, right? And this number over here on the x-axis would be less than this one. So I can see that in general, the more time somebody spends at the gym, the more calories they burn. And what I'm going to do for my trend line is simply draw a line through these dots over here, okay? It's the same thing that I'm going to do for this one. I can see that if somebody spends a lot of time, many hours surfing the internet, maybe just watching, to be honest, sometimes I'll watch like a cute cat video or something like that. I'm not immune to that either. But, you don't want to spend too much time doing that. And if you're wasting too much time just looking at these sort of crazy videos on YouTube or something, then maybe your GPA suffers. So here we can see that the trend is that the more time somebody spends surfing the internet, the more their GPA decreases, right? The GPA would go down. And over here, we can see that generally speaking, the more minutes spent working, somebody spends working on an assignment, the more questions they are able to complete. All right, so let's just again draw a line through these dots, okay, in a way which is representative of the trend that we see. Now, you might be noticing some points like this point over here, and this point over here, and this point over here, right? So now let me get back to this sentence which I didn't read before. Since outliers are not representative of the trend, it is okay to ignore them when drawing a trend line. So what is an outlier? An outlier is simply a point on the scatter plot, a data point, which doesn't seem to go along with the trend that we see for all of the other points. So for example, for this scatter plot over here, we can see that generally speaking, and remember that each one of these dots represents a different person. Okay, so generally speaking, the more time a person spent at the gym, the more calories they burned. However, we can see this person over here, the dot is way below where we would expect it to be based on how many hours that person spent on the gym. So this person, he's way to the right on the x-axis here. So this person spent a lot of time at the gym, but it doesn't seem like this person, if we were to draw a dotted line over to here, this would be a very low number for the calories burned, right? So even though they spent a lot of time at the gym, they didn't seem to burn very many calories. So maybe this was a person who went to the gym, but spent all the time in the lounge watching TV, or maybe just hanging out, chatting with friends by the water cooler or something like that, and didn't really spend time on the treadmill or with the free weights or anything like that. So they spent a lot of time at the gym, but they didn't burn very many calories. This would be an outlier for this scatter plot over here, because most people, if they did spend a lot of time at the gym, they burned a lot of calories. Same thing here. This would be an outlier. It doesn't seem to fit this the trend that we saw over here. So generally speaking, when these students over here, they spent many hours surfing the internet for who knows what, and then their GPA suffered. The more time they spent, generally speaking, their GPA went down. This person surfed the internet for a pretty long time, but was able to maintain a pretty high GPA. Okay, so we could come up with an explanation for that. We don't really know. We don't have that information. We can come up with a theory. Maybe the person was spending all that time on the internet researching things, actually using that internet time for educational purposes. That would be one theory. And we could come up with other ideas of why that might have happened. All right, over here we see another outlier. This person spent, let's see, so this is minutes spent working on an assignment and questions completed. So this person did not spend so much time. This would be a pretty low number on the x-axis, right? So maybe this person did not spend so much time working on an assignment, but they completed many questions. So this would be pretty high up on the questions completed on this axis over here. So we could come up with a theory for that, because generally speaking, if somebody, this trend here says that if somebody did not spend a lot of time working on an assignment, then we would expect that they were not able to complete many questions. But this person was. So we could come up with a theory about why that might have been correct. Maybe that was an assignment that they really understood very well, and they were able to complete all those questions because they knew what they were doing, even though they didn't spend a lot of time working on it. Or we could come up with another theory. Maybe that person was just rushing through and not spending too much time thinking about their work. So they're just kind of marking off a lot of answers without putting a great deal of thought into it. So that could be another explanation for this outlier over here. Okay, but I only spent a lot of time talking about that. But I want to read this sentence again. Since outliers are not representative of the trend, it is okay to ignore them when drawing a trend line. So this person over here is not really representative of the trend, so we don't have to worry about including this point when we draw our trend line. Okay, we don't have to change what our trend line is to accommodate this outlier over here. So I wouldn't have to draw anything like that to get closer to the outlier, because again, this would not be representative of what I see for the vast majority of the points. Okay, so I would want to keep my trend line more like that. And same thing over here. This line that I drew originally is pretty representative of most of the points that I see. I'm not going to change this trend line just so I can get closer, let's say, to this dot over here. So now this trend line may be going through that point, but it's not giving me the correct idea of what's going on for all the rest of the dots. So I really want my trend line to be representative of most of the dots. I'm not going to go out of my way with my trend line to accommodate just one or two outliers. Okay, and you can have more than one outlier on a graph. So let's change that to what it was before. Well, this is a much better trend line like that for what we saw on that scatter plot. All right, so let's continue here. Let's talk about bad trend lines. All right, so let's just say we have a bunch of data points over here, and I'm not even going to bother saying what's on the x-axis or the y-axis for this one. I just want to talk about bad ways to draw a trend line. So one bad way to draw a trend line is to draw your line above or below all the data points. So don't do that. Don't draw your line above or below all the data points. So for example, this would be a bad way to draw the trend line, because you can see all of the data points are above where I drew my trend line. So that's no good. You also don't want to do something like this, where now we can see all of the data points are below the trend line. That's also no good. Okay, what you want to do is draw the line through the dots. Okay, so you have some points which are above the trend line and some points which are below it. Okay, so something else that you might do is start your trend line always at the origin. You don't have to do that. You don't have to start at the origin. So for example, with this same scatter plot over here, some students might want to draw their trend line like this maybe, because they think that they have to start at the origin, they have to start at 0, 0. But you don't have to do that. And you can see that if you do that, sometimes you might get a good trend line. So for example, going back over here, you can see that starting at the origin for a trend line like this makes sense, because that's the way that the dots are. But for something like this, if you were to start at the origin, then you're really not drawing your trend line in a way which is representative of all these other dots over here. So you don't have to start at the origin. It depends on what the scatter plot is. Okay? Another thing that you don't want to do is you don't want to play connect the dots. So for example, some students will, I thought I played connect the dots when I was a kid, and it was fun, but that's not what we're doing here. This is not a trend line. This is a game of connect the dots like you might have played when you were in second grade or something. The idea of a trend line is just to give us a general sense of how the points are moving. We're not connecting every single point to every other point. Okay, so we should not be playing connect the dots here. We just want to draw our trend line through the dots just to get a general sense of what's happening with the data, to get a general sense of the relationship between the two the variable on the x-axis and the variable on the y-axis. Okay, so down here, if I wanted to draw my trend line, again, I'm not going to play connect the dots like this. That's wrong. That's no good. What we want to do is just draw a line through the dots like that. So you can see we have some dots above, some dots below, and this line is giving us a general idea of the relationship that exists between whatever variable we have on the x-axis and the y-axis. If it's time and score, or population versus income, or number of cats versus number of dogs, whatever it is, we just want that trend line to give us a general indication of the relationship that exists. Okay, and finally, another way that you could draw a bad trend line is to even draw a trend line at all if no relationship exists in the first place. Okay, so just getting back to this first example that we did, on this scatter plot, we can see that there is definitely a relationship between the number of hours somebody studies and the score that they get on the test. But over here, there is no relationship between somebody's height and the score that they get on the test. So for this one, we wouldn't even want to draw a trend line because that would be misleading. There is no trend. Okay, so if there is no trend, then there's no reason in even drawing the line. All right, so that's it, and have a great day.